Hello class, welcome to the next lecture on signals and systems, and today we will take a look at some examples and problems for the topic classification of signals. So let's start it. Okay, so let's see the first question. Question is, find even and odd components of x of t is equal to e to the power of minus 2t cos t. Okay. So what is the answer? We have x of t is equal to e to the power minus 2t into cos t, and we have x of minus t is equal to e to the power 2t cos t, right? So what is the even component? X e of t, that is equal to x of t plus x of minus t, right, divided by 2. So which is equal to e to the power of minus 2t cos t plus e to the power of 2t cos t whole divided by 2, which when rearranged properly we will get e to the power of minus 2t plus e to the power of 2t by 2 into cos t. Now this can be approximated as, not approximated, can be converted into what? Cos hyperbolic of 2t into this term says the same, into cos t. So this is the even part. Now what about the odd part? Odd part, x o of t is equal to x of t minus x to the x of minus t, the whole thing divided by 2, which is equal to e to the power of minus 2t cos t minus e to the power of 2t cos t divided by 2, which again when properly rearranged we will get e to the power of 2t minus e to the power of minus 2t by 2 into minus cos t. Okay, and this term becomes, or will become sine of sine hyperbolic of 2t. So this is minus sine hyperbolic 2t into cos t. So this is the even part and odd part of x of t. Okay, so that was a simple problem, and most of the problems in finding the even and odd components of a signal will be easy, because we just have to find x of minus t and replace it in the formula. It's easy, and I shall put more of these problems in the classroom. Okay, so that you can practice on that. Okay, so the next question is regarding from the topic periodicity of signals. So the question is, determine the fundamental frequency of the given signal, which is given as so what is it? This is a discrete signal, right? Because only these lines are just to show that a point is there. So only these values are there, these dot like things. So 1 0 1 2 3. Then we have 4 5 6 7 5 6 7. Then it again repeating from 8 onwards. Similarly, backwards it will be minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, 7, minus 8, again minus 9 onwards. So I'm assuming, pardon my drawing, I'm assuming that all the samples are having the same height, that is amplitude is same, and the distance or gap between each sample is the same. Okay. So how do we find the periodicity? First, what do we have to do? We have to find the number of samples which are repeating, right? So you can either take it like this much is repeating, or you can take like this much is repeating, right? Both are the same. So in that case, either way, how many samples are there? 8 samples are there. So we can take n is equal to 8. From that, what is the frequency? Fundamental frequency. Whenever we are talking about discrete signals, fundamental frequency is fundamental angular frequency itself, right? So this is equal to 2 pi by n, which is equal to 2 pi by 8, that is pi by 4, right? It is a simple question. So now let's see another question. The question is determine whether the following signals are periodic or not. If they are periodic, find, what do you have to find? Fundamental period. Fundamental period. Okay. So let's take two questions. So the first question is x of t is equal to cos squared 2 pi t, and let's take a second question as a what do we say, a discrete signal. So x of n, remember we have to put square brackets for discrete signals. X of n is equal to minus 1 to the power of n, right? So let's see how it goes. The first one. So you can see, you know that cosine is, cos of t is periodic, right? This is cos of t, and for this signal, like suppose let this be cos 2 pi t, right? Cos 2 pi t means for this the fundamental frequency is 1 second, right? 1 second, because this is 2 pi by t, right? This is 2 pi by t. 2 pi by t is 2 pi, therefore t is 1 millisecond. Okay, let me now how will cos squared of 2 pi t will be? How will it be? How will it be? It will be similar to this, but the shape will be somewhat different, in the sense it is squaring, right? So the rate of change will be different, and for our question, which is regarding the time period, the significant thing is that all this negative part will become positive, because suppose this is minus 1, right? Minus 1 squared will be 1. Similarly, all of these minus things will be becoming positive. So what is happening? This will be something like rate of change will be higher, it will be steeper curves, and it will be positive. So here what we can observe is, here actually this much is 0.5, this much is 0.5 seconds, right? Because 1 second is the time period. Here what is that won't change, that is 0.5 itself. The thing is that same 0.5 is repeating. Therefore for this one, this is cos squared 2 pi t. So here t is equal to 0.5 seconds. So this is, yes, this is periodic. This is periodic with t is equal to 0.5 seconds. That is the answer to the first question. So let's see the second question, which is a discrete one, that is x of n is equal to minus 1 to the power of n. Okay, let's just start drawing. So minus 1 to the power of 0, it is 1, right? 0, and it is 1. So, and minus 1 to the power of 1, it is minus 1. Minus 1 to the power of 2, again 1. Minus 1 to the power of 3, it is minus 1, right? So similarly you can get a pattern here. Likewise, minus 1 to the power of minus 1, that is 1 by minus 1 to the power of 1, that will be again minus 1. Similarly, plus 1, minus 1. So basically what is this? This is an alternating plus 1 minus 1 signal, and here n is equal to 1 only, because every time it is alternating. So this is, the answer is also yes, periodic with n is equal to 1. Similarly, I'll post some more questions for regarding periodicity, and in that there will be periodic and non-periodic. This is, in this example I am just showing periodic signals, but in that there will be both periodic and non-periodic signals. Okay, so now let's see some two questions regarding the power and energy of signals. Okay, so first question is, what is the power of this particular signal? So this is 0, 1, minus 1, and this is 0.2, 0.4, like that. Okay, so 0.4 is here. So this is 0.2, this is 0.4. Basically the one period is 0.2. So power is equal to 1 by t integral over a period, right? Over a period x squared of t dt, right? So basically what do we have to do? We have to, over a particular period, you can take a period like this, or like this will be going like this also, right? So you can take a period as this much, or you can take a period as this much, whichever is convenient to you. So basically the idea is that you have to square the signal and find the area over a particular period. So here, if I am taking this one particular period, okay, I am taking this particular period, I am squaring it, right? And squaring it means what is happening? Means this values for each value, right? For each value of time, for every value of time I am squaring it, and then I am finding the total area. Okay, so let's see how we can do this here. So this will be 1 by 0.2 integral 0 to 0.1, because this is 0.1. So I am taking the first half, 0 to 0.1. What is happening? 1 square dt, because this is 1 square dt plus 0.1 to 0.2 minus 1 square dt. Let's say it is minus 1. Okay, so what will be? It will be 1 by 0.2. So what is 1 squared is 1 dt integral is t. So t from 0 to 0.1 plus, again this is the same thing, t from 0.1 to 0.2, which is 1 by 0.2, 0.1 minus 0 plus, this is basic math only, minus 0.1. Okay, so what will be? It will be 1 watt the power. So what do we do for one period? Suppose if the signal is something like this, okay, or let's say it is something like this, how will you take the signal? You have to take, and this is 1, this is 1, this is for the convenience I'm taking the slow pass 1 and minus 1. So how will you do? Then you will have to take for a period 0 to 1 you have to integrate t dt, and from 1 to 2 you have to integrate what? Minus t dt, like that. Okay, so you have to take the particular function which you have to integrate, or particular function that is currently being evaluated. Okay, let's see another question. What is the energy of T1A? Okay, it is low. So basically it is just a and this is 0, this point is 0. So basically this is a single pulse with center as 0 and amplitude as A. So what is energy? Energy is equal to minus infinity to infinity x squared of t dt. Right. So here will be, so we don't have to take minus infinity to infinity because it's a finite signal and it is having value only at this area. And since the center is 0, we can assume that the signal is from minus t1 by 2 to t1 by 2. So it will be minus t1 by 2 to t1 by 2 a squared dt. So it will be a squared into t from, right, minus t1 by 2 to plus t1 by 2. So what will be? It will be a squared t1 by 2 plus t1 by 2, it is equal to a squared t1. So this is the energy of this particular signal. So if you have what do you say, a certain discrete signal, what will you do? Instead of integrating, you will find the sum of x squared of n. Okay, right. Integration itself is just a summation over a continuous signal or a continuous period of time. Okay, so that was some examples regarding classification, problems from classification of signals. So we started off with one for finding the even and odd components. I didn't do any problems for checking whether a signal is even or odd because that was very trivial, right? Then we found did a question for finding the fundamental period of a signal, and also also for a continuous signal. Okay, continuous and discrete both. And then we went on to find the power of a signal and energy of a signal. So I'll pose some more questions for different classifications in the classroom. You see, try to do that, and in the next lecture we will start with the different operations done on signals. Okay, thank you.